Section 11.5 is going to talk about more with circles, but now we're going to apply what we know about circles to the idea of an area. So instead of the circumference and arc length, we're going to be finding the area of a circle. And you're going to also notice a new word. We have this word sector. So we're going to define that in just a minute, okay? Let's start with what we already know. Area of a circle.
All right, we know the formula for area of a circle is pi r squared.
Good, and the r stands for the radius, so just kind of imagine that's your radius, okay? So pretty basic. Now that we have area involved, don't forget the area is different than circumference. Area is talking about how many square units inside that circle. Circumference is the distance around the circle. In other words, the perimeter of a circle in a sense.
So today we're thinking about just filling up the circle, like coating it.
So if I use 2 pi r, is that the same thing as that?
No, that was the circumference. That's a distance around. That's not the space inside.
Exactly. Area, again, is talking about square units. All right, so like square inches, square centimeters, whatever. Just be careful with when you're asked questions. I see every year I have students that will mix up area and circumference every single time.
Yep.
Right. So just to start, we have a couple examples, and we're going to encourage you to try these two on your own, just because it's just a little bit of recap of some things before. So try it out, and then check with us.
Okay. So as I'm looking at that first one, I noticed again we were talking about area of a circle. And the radius is 3, and if I've got the radius, I can easily find the area. Area equals pi times that radius squared. So 3 squared is 9, so we're going to call that just 9 pi to be exact. But since we've got meters, we want to go ahead and give the approximate value of that as well. So if I take 9 times pi, I'll get 28.27 approximately.
Now again, guys, and this is meters squared, notice because there's units, a rounded answer is kind of more feasible. But just a reminder that this value right here is your exact. Well, a lot of times you'll hear someone say, leave it in terms of pi. All right? I know that's a pretty popular phrase on our common assessments.
Yes.
This right here, of course, is your rounded answer. This is not as exact, of course. And again, remember using the pi button, not 3.14, because pi button's more exact than 3.14.
Right.
All right. So that one, piece of cake.
Yep.
Okay. What about the next one?
The next one, I know that they're first of all giving me we're finding the diameter, not the radius. The formula for area only deals with radius. It does not deal with diameter. But once I know the radius, I can double it to get to the diameter.
Good.
Okay, they give me the area in this one, so I'm going to put my 254 as my area and equals our pi, and I'm going to leave it as pi r squared right now.
Okay.
Because I can't put a d in that formula. So if I take that 254 and I divide by the pi part, so I'm just left with the radius squared, I'd end up with about 80.85 for my radius squared. And I would leave that big long decimal in my calculator. And when I divide by, when I square root to undo the square, I should end up with approximately 8.99. Not quite 7.
Not quite 9.
Or not quite 9. What am I even thinking 7? I don't know where my brain
That's
is.
okay.
Oh my gosh. And then if I double that to get to the diameter, that's going to give us approximately 17.98.
And this is this going to be square meters?
That would be just meters because the area is the units that are squared.
Yes.
But those linear measures are just regular units.
And I've seen some people do that recently with just putting the squared. So be careful with that. So again, notice since they give you the area, you're kind of working backwards. You're finding the radius, and then because they ask for the diameter, you can just double it. Okay.
Love it.
So, and here's the deal. You could always check it. You know, whatever you get the radius of, square that times by pi to see if the area, again, with this being a rounded answer.
Yeah, I would use what I left in my calculator and square it and then times
And I love, and remember, leaving that in your calculator. I love that you said that because there's no reason to type this in again. And when you type this in again, this 80 point 0.85, you're going to be further away from the exact answer because then you're going to have to round again and then round again. So just something to be careful with. Okay.
Okay, so new vocabulary term. The sector of a circle. It is the region that is bounded by 2 radii. So if you look up in my picture right here, I have 2 radius right here. And it is bounded by those and their intercepted arc. But it is talking about the whole region that's bounded. It's the area of that, really kind of like a piece of the pie. All right, it's just a chunk of my circle.
You know what makes me think of? Have you ever played that game Trivia Pursuit?
Yes.
And the Trivia Pursuit has that where you're having to fill in the little sectors to basically win the game. Yeah, I'm terrible at that game though.
I am too. I don't play it very often. All right. So when we talk about the area of a sector, we're talking about the ratio of the area of a sector and the ratio of the area of a sector of a circle and compared to the area of that circle is going to be equal to the ratio of the measure of the intercepted arc compared to 360. We're going to be comparing some ratios.
So when you say a ratio equals another ratio, essentially you're going to see a proportion.
A proportion. And just like we talked about before, we talked about degrees out of 360. We've seen that with that measure of the intercepted arc. So the measure of arc AB, in this case, compared to our 360, our total degrees, is going to equal. But in this case, we're looking at areas, not circumference. Before we did the arc length compared to the whole circumference. Now we're going to do the area of this sector compared to the area of the entire circle.
Okay.
So I'm going to just say area. In fact, I'm just going to use a big A for area. So area of sector compared to the area of the circle.
Now, before we move on, just notice again, she compared this to that idea of the arc length. Notice this proportion still has that measure of the arc to the whole 360. That is important for you to understand because you still need to know basically what part of the whole thing we need, okay? And to find the area of that sector, we need to know basically what fraction of the whole thing are we trying to figure out, okay?
Right.
And knowing that degree and measure will help us figure that out.
Yes.
All right, so let's try some examples. We'll just start with a basic one. It says find the area of the sector, okay? So one thing you'll see a lot of times, they'll just say find the area of the shaded region, okay? Because technically, this problem has this sector here that's shaded, but this stuff is considered a sector too because it's bounded by 2 radii and an arc. So technically there's 2 sectors, but usually the directions will say find the area of the shaded region, just to clarify. All right, so how we do that, to find the area of a sector, remember, area of your sector always compares to the area of the whole circle. And notice how Ms. Hokaby drew that circle with a little center in it. That allows you to kind of shortcut things.
Yes, don't just leave it as a circle with no center, or you don't know it's a circle
well,
or
and then
a 0.
it looks like an O or 0.
Right.
Okay, so then that is the same thing as your arc measure, okay? So your arc measure, whatever that is, or
that's in degrees.
The degrees to the 360. Okay, so again, this is dealing with degree amount. This is dealing with square units. Okay,
Right.
So since we don't know the area of the sector, right, that's going to be our unknown. Okay, we can say X, we could call it A, whatever you want to do it. What do you want to call it?
Let's call it A.
Okay, over. Now, how do you find the area of a circle?
Pi r squared.
And they give you the radius is 11 equals, what's the arc measure?
The arc measure is 135 out of our 360.
Now I'm going to go ahead and put A over 121 pi
Right.
equals, and then we could simplify that, or you can leave it just how it is.
Yeah, and we'll go ahead and just leave this one. All right, so I know that I'm going to cross multiply here, and I'm going to end up with 360A. And when I type that in my calculator, I've got 135 times 121 pi.
Or you could just type in 121 and just leave it in
Let's
terms
do it
pi.
exact right now. Yeah, 16,335 pi. Let's leave it exact.
And then what are you going to have to do?
And then I'm going to divide by the 360. Now, be careful when you're doing this. You could divide first by the 360 and then take your answer times pi, or you could go ahead and multiply this answer now times pi and divide by 360. We've got units, so I know I'm going to want a rounded answer on this one anyway. So I wouldn't even worry about simplifying that. Either way, divide by 360, I end up with 142.55.
And this is meters squared.
squared.
Now, guys, sometimes you might have to leave it in terms of pi. Again, if there's units, that's kind of a giveaway, all right? But sometimes you'll have to do that, so just something to kind of keep in mind. We've talked about that already, all right? So hopefully you're looking at this and you're like, this is just like what we've been doing. But now we're dealing with area, and that's exactly it, okay?
All right. The next one says that L and M are points on circle R, and we always name circles by their center. So when you see circle R, that's a circle with its center at R. The radius of 50, so I'm going to go ahead and mark that on my picture, and I could mark that on either one of these. And we know that the measure of angle LRM, so LRM is 150 degrees. We're going to find the areas of the sectors, plural, formed by that angle. Because where do you see sectors?
There's actually two of them. There's the kind of the smaller one that has that central angle of 150 degrees. And then there's the other one that's remaining.
Right.
So there's technically, anytime you have two radii in a circle, you're going to have two sectors.
Exactly. All right. Do you want to start with the smaller one?
Yeah,
or-
let's do that. Let's
Okay.
find the smaller sector.
How would I go about doing that?
All right, so we're going to do, we don't know the area of that, so we could call that maybe capital A again, over pi r squared, so pi times 50 squared, equals the measure of that central angle arc, which is 150, over 360.
Wonderful. Okay.
Okay?
And we'll
so
go
that
on.
would be A over, 50 squared is 2,500. So A over 2,500 pi.
You want to simplify this one?
Let's do that.
I know I could at least just simplify 15 over
So it'd be
36.
5 over 12.
There we go.
You don't have to, guys. Okay. The only good thing about simplifying, I shouldn't say the only good thing. The really good thing about it is especially when you have to leave an exact. Since there's units here, that is one where you could bypass it. But if you needed to be exact, if you simplify earlier, then you don't have
Saves
to
you
simplify.
some trouble
Uh-huh. So cross multiply, so it's going to be 12a times, or equals, sorry, if I can say it right. It would be 12,500 pi. And then you're going to divide each side by 12. Now, because it has centimeters, I'm just going to go ahead and
Give me the rounded.
get rounded
Sounds
rounded
good.
answer. So you're going to multiply that times pi, the 12,500, and then divide by 12, and you end up with about 3,272.49.
All right. And because this is area, and they give us a label here, I'm going to say this is going to be centimeters
Squared.
squared.
So that's the smaller area.
That's the smaller one. Now, as I just cut off the square. Okay. I know I'm not done yet, though. I'll just leave it. I also am supposed to find the other sector.
Okay.
So let's find the larger one.
Now, here's what I'm thinking. I could do that same process, but I know that the other areas, that other sector, is basically what's remaining of the whole entire circle. So if I know the area of the whole entire circle, which I can find that, and then subtract off the area of what I just found, I have what's remaining.
That should work perfectly.
Okay, so I know the area of that one is 2,500 pi. And I'm going to subtract off that 3,272.49. Now, here's the deal. I already have that in my calculator, so I'm just going to hit 2,500 pi, minus, and I'm going to put second answer, that recall, answer recall. And I get, what's left is 4,581.49
Awesome.
centimeters squared.
Now, again, if you wanted to go through that process and figure out, okay, how many degrees would be remaining over here and do the exact same setup.
So what
would work.
would basically be different? that a over 2500 pi would still be the same, but then instead of 150 over 360, it would be 210
Right.
over 360.
You got it.
So it should still work. Now, the good thing about kind of doing it that way is you could check your work.
Yeah, and you could make sure that these two do add together to give
Yeah.
you that 2500 pi. So just a couple approaches.
All right, something a little different. It says find the area of the shaded region. And again, those are the directions you'll see a lot. Now, do you see a sector in this one?
There's not a sector.
No, because there's no region bound by two radii.
Radii.
But what is it you're seeing in this picture?
Well, I see it looks almost like I don't know, kind of like part of a target.
Uh-huh.
Where it's a circle within a circle.
Yeah, there's two circles in it. Mm-hmm. Now, we want just the shaded region.
Okay.
So the smaller circle obviously is not shaded.
Right.
Okay, so this is not the shaded region we want. Obviously, it's not shaded. And the whole entire larger circle actually includes that smaller circle, right?
Right.
So how are we going to find the area of basically the rim in a sense?
It's almost like we need the area of the large circle, but then we need to take out that area of the smaller circle.
Exactly. Let's write kind of the game plan. So we're going to find the area of the larger circle, and we're going to subtract off, which is taking out the area of the smaller circle. It's kind of like, it's almost like it's like a donut or something.
Yeah.
Or like a tire. Mm-hmm. Okay. You're wanting just what's remaining. All right. So how do you find the area of any circle?
Oh, well, that's just pi r squared.
Okay. So we're going to remember that area of any circle is pi r squared. So for the larger circle, we need to know the radius of it. All right. So if we're talking about the larger one,
Well,
that
whole
would be
radius,
the whole distance, right?
Yeah, and that would have been 7.
All right. So we're going to do pi times 7 squared, right?
So
which gets you
49 pi.
And would we want to type that in our calculator?
I'm just going to, there's no units here,
Exactly.
so we can leave this
Let's
exact.
leave it. And guys, what's the point?
Right.
We don't even need to, we can do this in our head. All right. Now we need to find the area of the smaller one. So that means we need to go to the radius.
So the radius of the smaller circle is just the 5.
Okay. So that's just this piece right here. So then you would do pi times
5 squared.
5 squared.
Or 25 pi.
Now,
So
what are we
really,
doing with those?
I'm subtracting 49 pi minus 25 pi.
Can we actually subtract these?
Yeah, because they're like terms. They both have, they're in terms of pi.
Perfect. So that becomes,
Are 24 pi.
and notice again, I love leaving it in exact terms when it comes so convenient like this.
Oh,
I don't
yeah.
even need to touch a calculator. It's super quick. You know, we can handle it.
Yeah.
Okay?
Love it.
Good.
Okay. This one says, again, find the area of the shaded region. And are we talking about sectors in this circle?
No, there's no shaded region that's bounded by two radii. Now,
Right. They
I
give
do
us
see a radius,
and that's good.
and I see some shaded region, but it's not formed by two radii.
Okay, so what do you notice about this picture? What makes up that shaded region?
Well, okay, it's kind of, I think, similar to, we're going to do approach like the last one, but instead of having two circles making up that shaded region, is I see a circle and an equilateral triangle.
Right.
So I'm going to find the area of the whole circle, all right, and then I'm going to subtract off the area of the triangle.
Right, because we know that that triangle is not included in the shaded part, but the rest of the circle is.
We're going to take it away, basically.
Take it out. All right, so let's start off with our area of a circle. That's kind of the easier part here.
And that's because they give you the radius.
They
That's
give us
super
the
convenient.
radius.
So we're going to do pi times 6 squared, which is 36 pi.
Love it.
And we're going to leave it
Leave it
because
just
there's
like
no
that.
units. Okay.
Sounds great. Okay, now have this area of the equilateral. I love that you said that because we know that all the sides are the same. Equilateral triangle. Right now, all we know about it is the radius.
Which is not as convenient because when I think equilateral triangle, something to think about earlier in the chapter, to find the area of it, I could do the 1/4 side squared times radical 3. And I don't have the side length, but if I can find that side length, I can use that formula pretty easily.
I think that sounds wonderful.
So here's what I'm thinking. Let's draw in an apothem. Since this is a regular polygon, apothem, so you're going to draw a little segment from the center perpendicular to a side. And I'm going to find that little angle that's formed by that apothem and that radius, which is essentially half of the central angle. So I'm going to do 360 divided by 3. That gives you the 120. That's your central angle, but then I'm going to cut that in half. And that gives you 60. Now, I love that because it's a special right triangle. So a 30, 60, 90.
Right.
And I know the hypotenuse of that 30, 60, 90. So I can find the shorter leg.
Which is the one that's across from the...
30. So that's your apothem. So that's going to be 3, half of 6. And then I'm going to take that times, 3 times radical 3.
I just wrote a 6. I don't know why. Yeah.
So 3
3,
radical 3.
radical 3.
Now, that's only
Half
part of the side. So just be careful with that. We want the full side. So that's going to be double that. So that's 6 radical 3.
So that's our side length. And we know the formula, 1/4 side squared radical 3. So let's take 1/4 of that side length, that's 6 radical 3 squared times a radical 3. And that's really going to be 1/4 of...
108. Because you're doing squaring 6, that's 36. And then you're squaring a radical 3, that's going to be 3. So that gets you 108.
Love it. Times a radical 3. And when I take 1/4 of 108...
Which is dividing by 4, essentially. That's going to be 27. And then radical 3.
Okay, so we said our game plan was to take the area of the circle and subtract the area of the equilateral
so
triangle.
that would look like 36 pi minus 27 radical 3. Now, can I go ahead and do like 36 minus 27?
We can't. They're not like terms because they are not in terms of both pi or both in terms of radical 3. So really this right here is
That's
my
it.
exact answer.
Perfect.
Okay, now there's no units here.
Yeah.
So we would love it if you would just leave it like that.
And that's all you need to do.
Exactly. But if there were units, we could go ahead and actually type that in our calculator.